Welcome to our deep dive. We're going way beyond Imsi Ha today. We're really going to get to know the person behind that iconic equation, Albert Einstein. Our main guide for this deep dive is Walter Isaacson's biography,
hmm
Einstein, His Life and Universe. It came out in 2007,
hmm
and Isaacson actually had access to Einstein's personal archives. Plus, he talked to tons of experts. So we're really getting the full picture here,
Yeah.
not just the textbook version.
Yeah.
And honestly, what you'll learn about Einstein might surprise you. A rebellious streak,
Oh, yeah.
a messy personal life, a really complex relationship with his own fame.
It's true. Einstein's story is about so much more than just those breakthroughs. He really embodies this power of imagination and challenging what everyone just assumes is true.
Okay, so let's jump into what's called his miracle year, 1905. Einstein's only 26 at this point, and he's working as a Chapman clerk. Not exactly the image of a scientific revolutionary, right?
Right.
And
Yeah.
yet, he publishes 4 papers that totally shake up the world of physics.
And these weren't just like small changes to existing ideas. He was really redefining how we understand reality itself. What's amazing is that he accomplished all this outside the academic world, really,
Yeah.
purely driven by his own intellectual curiosity.
Wow. That's incredible. Can we break down those 4 papers a little bit? Because they
Yeah.
each cover totally different areas of physics, right?
Exactly. So first, there's his paper on the photoelectric effect. Before Einstein, everyone thought light was just a wave. But he builds on Planck's idea of energy, quanta, these little packets of energy,
Hmm.
and shows that light can act like a particle too. We call those particles photons now. And this basically kickstarts the whole field of quantum theory and eventually wins him the Nobel Prize.
Ceres. Because of Einstein, we have to think of it as both a wave and a particle.
That's right. Then there's Brownian motion. You know how the dust motes seem to dance around randomly in a sunbeam?
Mhm.
Einstein proved that that's because they're constantly being bombarded by these even tinier atoms that we can't see. This was huge because it gave us solid proof
Yeah.
that atoms actually existed, which
Great.
people were still debating back then.
So he basically connected this invisible world of atoms to the world we see every day.
That's amazing. Okay, so what about the other 2 papers from that year?
Well, the third one tackles special relativity. And this is where things get really mind-bending. He starts with 2 postulates, or basic assumptions. First, the laws of physics are the same for anyone moving at a constant speed relative to each other. And second, the speed of light is constant for everyone, no matter how fast you're moving.
Hold on. The speed of light never changes, even if you're racing towards it
Yeah.
or away from it. That doesn't seem possible.
It seems crazy, but it's been proven again and again. And by accepting these 2 postulates, Einstein shows that time isn't absolute. It can actually stretch or compress, depending on your motion relative to someone else.
So you're saying time travel is real. Not quite like in the movies. But it is the principle of time dilation. The faster you move, the slower time passes for you, compared to someone standing still. And that's just one consequence of special relativity. Distances can shrink. Mass increases as you approach the speed of light. It really upends our everyday intuition about how the universe works.
Yeah, I can see why it took people a while to wrap their heads around this. It makes those first 3 papers seem almost like warm-ups. For the 4th one,
You
right?
could see that. His 4th paper, 1905, was actually a follow-up to special relativity. And it contains that famous equation, EMC2. It describes the relationship between energy and mass, and basically says they're 2 sides of the same coin. Matter can be converted to energy, and energy to matter. That's the principle behind nuclear power and atomic bombs.
It's insane that he accomplished all of this in 1 year. But where did this unique way of looking at the world even come from? Was he always a science prodigy?
That's a great question. Isaacson actually takes us all the way back to Einstein's childhood. And it turns out his path to genius wasn't exactly straightforward.
Okay, let's go back then. I know there's that famous story about Einstein getting a compass as a kid and being completely mesmerized by it.
Right. He was 5 years old. And that simple compass sparked a lifelong fascination for him with what he called field theories. The idea that invisible forces like magnetism permeate space and influence how things behave. And this fascination would later lead to his theory of gravity, general relativity, which is also a field theory.
So a childhood toy led to one of those revolutionary theories in physics.
Wow.
But I've also read that Einstein wasn't exactly the ideal student. Didn't always follow the rules.
He definitely had a rebellious streak, especially when it came to rote memorization and obedience to authority. He despised the rigid militaristic environment of his high school in Munich. He even said he came to despise marching in step. This independent thinking was a major part of his personality and would later shape his political views as well.
So he wasn't afraid to question the status quo, even at a young age. Did that rebellious streak affect his early education at all? Like, was he a natural at math and physics?
Actually, no. He struggled with math early on, and his path to studying physics at Zurich Polytechnic wasn't typical. He failed the entrance exams the first time, mainly because of subjects like French and zoology.
Well, that makes me feel a little better about my own school days. So how did he end up at Zurich Polytechnic if he failed the first time?
They recognized his potential in physics and admitted him on the condition that he spent a year preparing at a different school in Aarau, Switzerland. The teaching there was much less rigid, focused on visual thinking and understanding concepts, rather than just memorizing facts. Einstein thrived in that environment.
Interesting. So it seems like that less conventional approach to education actually nurtured his genius. It's amazing how these seemingly random events can end up shaping someone's destiny.
Absolutely. And that's what makes Isaacson's biography so compelling. He connects these seemingly random pieces of Einstein's life, his personality, his intellect, the circumstances he found himself in, and shows how they all contributed to his incredible journey.
It's like a giant puzzle, and every piece, even the ones that seem insignificant at first, ends up being crucial to the bigger picture. But of course, we can't talk about Einstein without talking about his personal life, which was pretty complicated.
That's right. Before we get to the image of Einstein as this global icon, it's important to understand the man behind the myth and look at his personal life, his relationships, his struggles, his triumphs, to really grasp the depth of his character.
Let's dive in then. Isaacson doesn't shy away from those personal details, right? He even reveals the story of Einstein's first love, Marie Winteler, which isn't as well known.
Right. Their love affair unfolded during Einstein's time in Aarau. Isaacson uncovered this trove of letters between them that gives us this incredible glimpse into Einstein's emotional life. As a young man, they were deeply connected intellectually, bonding over their shared passion for music, literature, and these deep philosophical conversations about the universe.
They sound like a perfect match. Intellectually, at least. What happened?
Well, as Einstein's scientific ambition grew, he moved on to Zurich Polytechnic. And their relationship started facing challenges. The distance, their different paths in life. And maybe, as Isaacson suggests, Einstein's tendency to be a bit self-absorbed really put a strain on their bond.
It must have been heartbreaking for both of them.
The letters really show the intensity of their feelings and the sadness they felt as their romance faded.
And all of this is happening before he meets Maleva Maric, who would become his first wife.
Yes, Maleva Maric enters the picture later. When Einstein starts at Zurich Polytechnic, she was a fellow physics student, and their relationship would become this fascinating and complex chapter in his life story, marked by both intellectual collaboration and personal challenges.
I know there's even this mystery surrounding their first child, a daughter named Lyserl, who was born before they were married.
That's right. The details about Lyserl's life and what ultimately happened to her remain shrouded in mystery. It serves as this poignant reminder that even someone as iconic as Einstein had personal struggles and secrets that remain hidden for years.
Yeah, it's humbling to realize that beneath all the genius, he was this complex human being, grappling with life's ups and downs, just like everyone else.
Exactly. And understanding those complexities gives us a much richer appreciation of his achievements, both the scientific ones and the personal ones.
So we've got this rebellious student who challenges authority, a passionate love affair that ends in heart work, and a mystery surrounding his first child. It's clear we've only just begun to uncover the many layers of Einstein's fascinating life.
And as we continue our deep dive into Isaacson's biography, we'll uncover even more about the forces that shaped Einstein's mind, the unique way his genius worked, and the personal struggles that unfolded, alongside his scientific triumphs.
We're back, and I'm really curious to learn more about Einstein's relationship with Maleva Maric. She was a classmate of his at Zurich Polytechnic, and if I remember correctly, the only woman in their physics class. What really stood out to you about their dynamic, especially after, like, his passionate romance with Marie Winteler?
It's fascinating how different these relationships were. With Maric, the connection was much more intellectual at first. They were both so deeply passionate about physics. Their letters are filled with discussions of scientific problems, papers they were reading, even their own developing ideas.
So it sounds like more of a meeting of the minds than like a whirlwind romance.
Exactly. And it wasn't just casual chit-chat either. They had this pet name for their collaborative work, Our Investigations. You can really see the seeds of Einstein's future breakthroughs being planted in those early exchanges.
I love that,
Okay.
our investigations. It's so perfectly nerdy and sweet. They were both on the cutting edge of physics at the time, right? Weren't they particularly fascinated by electromagnetism and light?
Yes, they were wrestling with some of the biggest mysteries in physics. Remember how Einstein was intrigued by synchronizing clocks using electrical signals? That
Yeah.
fascination, which may have stemmed from his work at the patent office, would actually play a key role in his development of relativity.
How so? That seems like such a mundane thing compared to, like, the mind-bending concepts of relativity.
It's a great example of how Einstein could take a seemingly ordinary problem and extract these profound insights from it. He realized that if you could perfectly synchronize clocks using electrical signals, you could then use those clocks to figure out whether two events happening in different places occurred at the same time. We call that simultaneity.
Okay, I think I see where you're going with this.
Exactly. Einstein realized that simultaneity isn't absolute. It's relative to the observer's frame of reference. That's a key principle of special relativity. So his work on something as practical as synchronizing clocks actually helped him visualize and conceptualize the very nature of time and space.
It's incredible how a seemingly boring job could spark such revolutionary ideas. It speaks to his ability to see the extraordinary in the ordinary.
It does. And it reminds us that inspiration can come from the most unexpected places. But getting back to Mileva, they eventually did get married, right? And had children together.
Yes, 2 sons. But from what I've read, their relationship was far from a fairy tale. Isaacson described some pretty significant challenges they faced.
Yeah, unfortunately. Their relationship faced a lot of headwinds, both personal and societal. For one thing, their families weren't exactly thrilled about the match. Einstein's mother, Pauline, was particularly against it. She thought marriage was too intellectual and not pretty enough for her son.
Wow. Talk about a tough mother-in-law.
It gets worse. There were also cultural prejudices at play. Marriage was Serbian and Orthodox Christian, while Einstein came from a Jewish family, although a fairly secular one.
So on top of everything else, they had to deal with religious and ethnic barriers as well.
Yes, it was a lot to overcome. And beyond those external pressures, they also had their own internal struggles. Marriage was a brilliant physicist in her own right, but she really struggled to balance her scientific ambitions with the demands of being a wife and mother, especially at a time when women in science face so much discrimination.
That's heartbreaking, but
Oh.
sadly, not surprising. Even today, women in STEM fields face similar challenges.
It is a recurring theme throughout history, and it's clear that marriage's own brilliance was somewhat overshadowed by the societal norms of the time. Their letters show this mix of affection and frustration, revealing the complex reality of their relationship.
How do Einstein handle all of this? Was he supportive of her ambitions?
It's complicated. He definitely valued her intellect and enjoyed their scientific discussions, but he could also be self-absorbed and insensitive to her struggles. It seems he wasn't always the easiest person to be in a relationship with.
Kind of a mixed bag, like so many relationships are.
Exactly. Their story really raises questions about the challenges faced by couples who are both ambitious and intellectually driven, especially in a time with such rigid gender roles.
It also reminds us that even brilliant minds are human and face the same complexities and imperfections in their relationships as everyone else. But let's shift gears a bit and talk about Einstein's thought experiments. Isaacson really emphasizes how crucial those were to his scientific process. Can you explain why?
Absolutely. Einstein had this extraordinary ability to visualize complex scenarios in his mind, to play out the consequences of different theoretical ideas. He essentially had a physics lab in his head.
I love that. A physics lab in his head. That's the perfect way to describe it. He once said, "Imagination is more important than knowledge."
Right.
Yeah.
Yes, he did. And that quote speaks volumes about his approach to science. He wasn't afraid to question everything, to challenge the accepted wisdom, and let his imagination lead the way.
What were some of his most famous thought experiments? I know there's the one about chasing a light beam, which led to special relativity, but I'm curious about the others.
Well, another famous one, which he called his happiest thought, involved picturing a man falling from the roof of a building.
Wait, falling from a roof? That doesn't sound very happy to me.
It wasn't about the fall itself, but what the falling man would experience. Einstein realized that someone falling freely wouldn't feel their own weight. They'd feel weightless, just like an astronaut in orbit. This led him to a profound realization. Gravity and acceleration are equivalent. What we feel as gravity is actually the same thing as acceleration.
So the feeling of being pulled down by Earth's gravity is the same as the feeling of being pushed back in your seat when a car accelerates.
Exactly. It seems counterintuitive, but it's a truly mind-bending insight that connects gravity to the very fabric of space-time itself.
That is wild.
It is, and it's a testament to the power of thought experiments. Einstein used them to explore the fundamental nature of reality in a way that no physical experiment could.
It's like he was playing with the universe in his mind, testing out different possibilities and seeing what made sense.
That's a great way to put it.
Yeah.
Now, Einstein's genius obviously went far beyond physics. Isaacson mentions that he was deeply influenced by philosophers like David Hume and Ernst Mach. You can see their influence all over Einstein's work. Hume questioned the nature of causality, why we assume that one event causes another, and Mach challenged Newton's idea of absolute space and time. These ideas resonated with Einstein's own questioning nature and his desire to build physics on a foundation of observable phenomena.
So philosophy was like another playground for his mind, a way to explore the deeper questions behind the scientific equations.
Exactly. He saw connections between philosophical ideas and scientific questions, and he wasn't afraid to draw inspiration from both.
And speaking of inspiration, wasn't he also a passionate musician? I read that he loved playing the violin.
He did. He was particularly fond of Mozart and saw a deep connection between the beauty of music and the beauty of the universe. In fact, there's this beautiful quote from Einstein about Mozart in the book. He said that Mozart's music was so pure that it seemed to have been ever present in the universe, waiting to be discovered.
I love that. It's like he saw this underlying harmony in both music and physics, the sense of order and elegance that transcended any particular discipline.
It's a beautiful thought, isn't it? And it reminds us that creativity often thrives at the intersection of different fields when we're open to seeing connections and drawing inspiration from unexpected sources. That's when truly innovative ideas emerge.
Speaking of innovative ideas, we can't go any further without talking about ECPU. It's the equation that's practically become synonymous with Einstein's name. And it's such a deceptively simple formula for something so profound. Can you break it down for us?
Of course, EC2 is describes the relationship between energy, E, mass, M, and the speed of light, C. What it essentially says is that mass and energy are two sides of the same coin. They're equivalent and can be converted into each other.
So matter can be transformed into energy, and energy into matter.
That's right. That's the principle behind nuclear energy, both the destructive power of atomic bombs and the potential of nuclear power plants.
It's mind-boggling to think that this simple equation has had such a profound impact on the world.
It has. It's a testament to the power of scientific inquiry and the enduring legacy of Einstein's genius. But remember, even with all the amazing discoveries we've talked about, we've only scratched the surface of his life and work.
I know. It feels like we've covered so much ground already, but there's still so much more to explore.
Exactly. We've laid a solid foundation for understanding the key influences that shaped Einstein's thinking. But in the next part, we'll delve into the later years of his life and career, a period marked by global fame, new scientific challenges, and his emergence as a powerful voice for peace and social justice.
Welcome back to our final dive into the world of Albert Einstein. It's amazing to think that this man who started as a rebellious student and a patent clerk would go on to become a global icon.
His journey is really a testament to the power of curiosity, imagination, and challenging conventional thinking. We see how those early experiences and relationships really shaped his unique perspective. But in this final part, we'll explore how he navigated the complexities of fame, grappled with new scientific frontiers, and used his platform to advocate for a better world.
Let's start with his rise to global fame then. I know there was a specific event in 1919 that really catapulted him into the public spotlight. What happened?
It was the confirmation of one of his boldest predictions, that gravity bends light. This came about during a total solar eclipse, when astronomers could observe the positions of stars near the sun. Einstein had predicted the sun's gravity would actually warp the fabric of space-time, causing the starlight to bend as it passed by.
That sounds straight out of science fiction. Did his theory hold up?
It did. British astronomers, led by Sir Arthur Eddington, meticulously measured the starlight during the eclipse and found that it was deflected, exactly as Einstein had predicted. This confirmation of general relativity sent shockwaves through the scientific community and made Einstein an overnight sensation.
That must have been a surreal experience for him. One day you're a physicist, working on these complex theories, and the next, You're a global celebrity.
Imagine that. He was suddenly inundated with requests for interviews, lectures, appearances. His face was on magazine covers. Everyone wanted to know more about the man who had seemingly unlocked the secrets of the universe.
It sounds both exhilarating and overwhelming. How did he handle all that attention?
While he enjoyed the recognition to some extent, he also found it burdensome at times. He remained dedicated to his scientific work. But he also became acutely aware of the social and political implications of his fame. He couldn't just be a scientist anymore. The world expected him to be a voice on important issues.
Thinking of which, he became quite a vocal advocate for peace and social justice, didn't he?
He did. Einstein was a lifelong pacifist, and he was horrified when his famous equation, E mesorum, was used in the development of atomic weapons. After the bombings of Hiroshima and Nagasaki, he became even more outspoken in his advocacy for peace and international cooperation.
It must have been a heavy burden, knowing that his scientific breakthroughs had, in a way, paved the way for such destructive power.
Absolutely. He felt a deep responsibility to speak out against the dangers of nuclear proliferation. He co-authored the Russell-Einstein Manifesto, urging world leaders to seek peaceful solutions to international conflicts and warning about the existential threat of nuclear war.
His commitment to social justice went beyond just nuclear disarmament.
It did. He was also a fierce critic of racism and prejudice, having experienced discrimination firsthand. As a Jewish scientist in Nazi Germany, he understood the devastating impact of intolerance. He was a vocal supporter of the civil rights movement in the United States and spoke out against all forms of injustice wherever he saw them.
It's inspiring to see him using his platform to advocate for a better world. But did he continue to make significant contributions to science amidst all of this fame and activism?
He did, although perhaps not at the same pace as his miracle year. One of his main focuses was developing a unified field theory. He was searching for this single, elegant theory that could explain all the forces of nature, gravity, electromagnetism, the weak and strong nuclear forces.
So, essentially a theory of everything.
Exactly. It was a monumental undertaking that consumed him for decades. While he wasn't ultimately successful in finding that elusive theory, his relentless pursuit advanced our understanding of physics in profound ways.
It's fascinating that even someone as brilliant as Einstein faced challenges and setbacks.
It shows that even the greatest minds don't have all the answers, and the pursuit of knowledge is a lifelong journey. He also grappled with the emerging field of quantum mechanics, which described the behavior of matter and energy at the atomic and subatomic level.
And if I remember correctly, he wasn't exactly thrilled with some of the implications of quantum theory.
He wasn't. He'd actually helped lay the groundwork for quantum mechanics with his work on the photoelectric effect. But some of its core principles, like the idea that the universe is fundamentally probabilistic, clashed with his deeply held belief in a deterministic universe.
He famously declared, God does not play dice with the universe.
That's right. He believed there must be a deeper, more fundamental explanation for the workings of the universe, one that didn't rely on chance or probability.
So even when faced with a theory he helped create, he didn't shy away from questioning and challenging its fundamental assumptions.
Exactly. That's a hallmark of true scientific inquiry. Einstein's willingness to constantly question and explore, even his own ideas, is a huge part of what made him such a revolutionary figure.
As we wrap up our deep dive, I'm curious about your thoughts on Einstein's lasting legacy. How has he shaped the world, beyond just his scientific contributions?
On a scientific level, his theories of relativity completely transformed our understanding of space, time, gravity, and the universe itself. His work on the photoelectric effect paved the way for quantum mechanics, and his famous equation, EC-seal, became the cornerstone of nuclear energy.
But his impact goes far beyond just the equations and theories, right?
Absolutely. He became a global icon, a symbol of intellectual brilliance, creativity, and the power of the human mind. His name is synonymous with genius, and his image is instantly recognizable all over the world.
He also left behind a powerful legacy as a humanitarian and advocate for peace.
He did. His outspoken pacifism, his commitment to social justice, and his willingness to use his platform to fight against injustice continue to inspire people to this day.
It's truly remarkable that one person could have such a profound impact on the world, both through scientific achievements and humanitarian efforts.
It is. And it's a reminder that true genius lies not just in intellectual brilliance, but also in the courage to challenge conventions, to use one's talents for the betterment of humanity, and to never stop questioning and exploring the mysteries of the universe and ourselves.
Well said. I think this deep dive has given our listeners a lot to think about. We've explored Einstein's incredible journey, from his rebellious beginnings to his global fame, his groundbreaking scientific discoveries, his struggles with quantum theory, and his enduring legacy as a scientific and humanitarian icon.
It's been a fascinating journey through the life and universe of one of history's most remarkable minds. And it's a story that continues to resonate today, reminding us of the transformative power of curiosity, imagination, and a relentless pursuit of knowledge and understanding.
If you're eager to learn more about this extraordinary life, we highly recommend Walter Isaacson's Einstein, His Life and Universe. It's a captivating read that captures both the brilliance and the humanity of this remarkable man.
And if you're interested in exploring the stories of other innovative minds, Isaacson has also written acclaimed biographies of Benjamin Franklin and Steve Jobs.
I'm definitely adding those to my reading list. Thanks for joining us on this deep dive, everyone. We hope you enjoyed the journey.